We can't ignore this subject because we humans are clearly an integral part of our environment, whether we want to be or not. The activities of humans can restrict ranges of naturally occurring species, and in other cases can actually increase the sizes of ranges. We exploit organisms. We use them for our own purposes. Way back when agriculture was invented, for example, we chose plants that we wanted to grow in order to enhance our ability to get food. We started raising animals for our own use as well. And as humans moved from place to place, we purposefully brought these organisms with us, and those organisms had their ranges extended. Estuaries are often brought up as examples of invaded environments. San Francisco Bay is one of the most invaded estuaries on the planet in terms of introduced new species. You're seeing types of organisms that were introduced by human activity by accident, primarily through the movement of ships that carried those organisms to docks and into our harbors. Now, those organisms find themselves in a place where they can live and they proliferate throughout the estuary. Sometimes a single species can totally dominate the habitat. Which brings us to the question of huge biomass but low species richness. We love to grow crops, but what we like to do with our crops is to make sure it's only that one species that grows in those many thousands and thousands of acres or hectares. To be provocative, I often say that the single greatest environmental change to be perpetrated on the North American continent is corn. Because corn is grown in a monoculture. Nothing else is allowed to grow with the corn. Nothing that eats or competes with the corn is allowed to be there. So the species richness of the millions of acres of cornfield across the U.S. is extremely low, about as low as you can get. There's high biomass, sure, but what was there before we planted all that corn? Much higher species richness. Those prairies were very biodiverse. That richness is preserved in some small pockets here and there, but you can obviously see that the biomass of those wild populations is much lower and their ranges much smaller.
The distribution of wildlife poses some puzzles for modern biologists. Why do we find giant land tortoises on islands in the Pacific Ocean and 10,000 miles away in the Indian Ocean, but nowhere in between? Why do we find identical plants on either side of the Atlantic Ocean? These kinds of disjunct or split ranges can't be explained by the way organisms travel and live in the present. The worldwide flood described in the Bible and its effects on the earth may offer essential clues to explain these split ranges. Of course, many fish were able to survive outside the ark. Even freshwater animals could survive. Many people don't realize that fresh water from rivers like the Amazon can float for years above the ocean without mixing. So freshwater animals could survive the flood in fresh water, floating above the salty ocean water. Many plants that weren't on the ark could have floated during the flood, some even in the floating freshwater. As the floodwaters receded, plants and fish would have been left behind at lakes and other places around the world. Many plants would have continued to float, providing a way to distribute animals after the flood. After Mount St. Helens erupted in 1980, hundreds of thousands of Douglas fir trees were ripped up and remained floating on the lake 25 years later. If Noah's flood ripped up every forest in the world, mats of trees probably stayed afloat for centuries. As winds blew these enormous log mats in circular paths in the oceans, they would have served as rafts for animals to cross oceans. Rafts may also explain how tortoises got to remote islands. Interestingly, most modern animals and plants with ranges split across oceans follow the pattern of modern currents. Their distribution can be explained by rafting. In this way, the flood and its aftermath provide a solution for one of the many mysteries of biology: split ranges.